and technology, the science and technology of extracting metals, the science and technology of extracting metals from the ores. See what I mean here. Ores, O-R-E-S, ores. From the what? Ores. From the what? Ores, that's all. The question now is, what is ore? Who can tell me what an ore is? Ore. Pardon? Have you heard of mineral before? Some of you, most of you do pick up stones, throw around, even times trying to use those stones to break glasses. I don't blame you. If we are living in a good country, I don't think you can see such stone, because those stones you throw around are vital. They are minerals. The stones you throw, you used to play, we can get iron from them. We can get other valuable materials from them. So they're supposed to be very, very useful. But you play with it because you don't know the value. Is that your fault? Not your fault. So now, I know most of you have heard of this word mineral. True or false? Now, when we talk about mineral, we don't mean the Coke you drink. We don't mean the Fanta. Because when you have a visitor, you ask the visitor, should I get a mineral or alcohol? I know you do say this kind of thing, right? Huh? If you have a visitor, what will you ask the person? Will you ask the person to take mineral? You ask the person to take what? Fizzy drink or soft drink, whatever way you call it. Fizzy. Fizzy. Do you know why we call it fizzy drink? Why is it called fizzy drink? If you open it without taking it that time, the value will depreciate. I want you to do an experiment. Get Coke, maybe, or Fanta, open it. Open it. What do you say? Okay, buy and share. That one follow. So, we will buy, if you buy one, open it, take small that time, and check the test. Open it and leave it for some hours, go and test it again. Will the test change? Okay. So, will it change? Will it be more, will it give you a better test than before, or lesser test than before? So, that means it has fizzled away. That is why it is called fizzy drink, right? So now, fizzy drinks, that just fizzy drinks, are not minerals. Now, when we talk about minerals, we talk about what? Naturally occurring substances. Naturally occurring substances. Minerals are naturally what? Occurring substances with wide range of compositions. That's what minerals are. Naturally occurring substances with wide range of compositions. Wide range of compositions. That's what we call minerals. So the stones you see, are they minerals? Can you think of any mineral from what I said now? Can you think of any mineral? Yes, lodestone, correct. Can you think of any other mineral? Can we think of any other mineral? Bauxite, yes. Limestone, Coal. Coal is classified as fossil fuel. Fossil what? Fuel. Fossil fuel. I want us to know the difference between minerals and crude fossil fuels. These few things are not exactly the same, but we will differentiate them. So now, What do we say that minerals are? Naturally occurring substance with what? So they have things that they are made of. That is what we call minerals. Now, from minerals, we get ores. So what are now ores? Ores are what? Minerals. Ores are minerals from which minerals whereby metals are extracted economically. Ores are minerals whereby metals are extracted economically. Ores are minerals whereby metals are what? Extracted economically. Who can tell me the meaning of that word economic? Economic. What does that mean? If I say I am being economical, what do I mean? What do I mean? Okay, let me put it this way. If you say that something is economical, what does that mean? It's cheap, right? So it's not that too expensive, which means you are trying to control cost, true of us. So that is what that means. Now, when we say ores and minerals, whereby what? Metals are what? Extracted economically. Those minerals that we can get metals from at a cheaper cost. At what? Now, let me tell you this. If you invest 1 billion naira in a business, and at the end of the day, after making sales, and we realize only 500 million, will you do that business again? You invested 1 billion, and now after making sales, the whole sales, you can only realize 500 million. Will you do that business again? So that is it. So it is not all minerals that we can get metals from. Though all minerals may contain metals, but we cannot get what? Metals from all minerals. So those minerals we can get metals from are what we call what? Are what we call what? So anytime you hear ore is talking about minerals that we can get metals from. Is that right? Good. So now, coming to ore, there are various ores. Like for instance, there are various ores and there are various minerals. Let me tell you this. Can you give me any aluminum mineral you know? Aluminum minerals. Anything you know that contains aluminum. Pardon? Tell me any minerals you know that contain aluminum. These are things you should be expecting in JAMB. Have you heard of clay? You know clay? Okay, me febu clay. Ajuro ka inso ya n'Igbo. Okay, ma ajuro. Do they use it to make pots? Have you asked yourself why they were using it to make pots? It is because it can conduct what? It can conduct what? I don't like the word heat. Say it can conduct thermal energy, not heat. Are you with me? I don't want to go that way. Let's just calm down. Just say thermal energy. That's the right thing to say, not heat. Heat is just a way of transferring thermal energy. Is that right? Like if I place a pot on fire, what am I doing to the pot? I'm heating it, right? So I'm heating the pot, okay? But the energy, the pot will receive something from the fire. What is that thing to receive from the fire? Thermal energy. Now you are talking. Thank you. Because you have to be thinking and talking like a scientist. Is that right? Thank you. Now, we proceed. So clay is an aluminum mineral. Is there another thing you can get aluminum from? Is there another thing you know that contain aluminum? This is a jam question anyway. Have you heard of mica before? I've heard of mica. Mica is a mineral too. Maybe we can, Mr. Faces, is it possible for us to go to Google? Maybe, can your media bring out the picture? Let them see what mica is. Okay, let them bring it. Find out mica so that they can see the picture of mica. Visual and audio learning is very necessary. Let them see mica. You also have feldspar. You also have this. Have you seen it? Have you seen mica? Have you seen mica? Who can tell me, as a scientist, who can tell me one thing you know mica is used for? Tell me one thing you know mica is used for. Mica is a dielectric. Mica is what? You know what is dielectric? We normally call dielectric. In fact, the word dielectric means electrical insulator. Electrical what? All insulators used in the electric circuit are called what? Dielectric. I would mean, anytime you hear the word dielectric, it simply means electrical what? Insulator. A medium that can prevent positive and negative charge from reaching each other. Is that right? That is dielectric. That is dielectric. So, of course, this thing is, you find this in your electronics. Okay? And where do you find it? In capacitors. In where? Capacitors. In capacitors. So, aluminum is there. Aluminum is there. There are other aluminum minerals. You have bauxite. You have this, corundum. How many of you have seen corundum? How many of you have heard of corundum before? Do you know that thing they use to, welders use to clean gates? I mean, before painting it. That is very rough, abrasive, you know that? So this is corundum. Corundum is a hard aluminum mineral, very hard. So you can also bring up the picture. Let them see corundum. If you also go to Ogbete, you see people that use it to sharpen knife. You know that? Have you seen that thing that black thing that looks like stone? They use to sharpen knife. Have you seen it? That is also corundum. That's an aluminum mineral. But of all these minerals here that are aluminum, that have aluminum, it is very expensive to get aluminum from them. So the only one we can get aluminum from is what? And for that reason now, they can ask you in exam, which of the followings are aluminum minerals, but one is an aluminum ore. What will you choose? Bauxite. So it means that the only raw material we can get aluminum from, the only natural raw material we can get aluminum from is from what? Is what? Is what? Bauxite. So bauxite is an aluminum ore. The only aluminum ore is what? The only aluminum ore is what? Bauxite. The only aluminum ore is bauxite. The only aluminum ore is bauxite. So there are many ores. So we will not waste much time. Let's just move straight. We have given you some hints. So let's now go to the main thing we need to do. Now, before we proceed further, we'll be talking about every element. We'll talk about the minerals. Now, before we proceed, I want us to look at basic stages. That is the basis of jam questions in metals. Basic stages in metallurgy. Basic stages in what? What is the first stage? Class, if you dig something from the ground, will it be mixed with other things? Eh? Anything you collect from the soil, will it mix with other things? It mixes with other things. So there is need to separate them from those things that are made of, right? Good. So the first stage is what? Concentration or purification of ore. That is the first stage in metallurgy. How do I separate the ore from those other materials that accompany it? So let me tell you what is involved here. What do you mean by concentrate? Have you been told to concentrate before? What does that mean? If, for instance, now I notice you are not following me and I ask you to concentrate, do you know what I've asked you to do? Because I notice you are far. I want you to come closer. To concentrate means to come closer. To do what? To come closer. That is the meaning of the word concentrate. Now, I want you to understand this. If I have like a mineral, like an ore, and I have many particles, these are various particles. Watch this now. These big ones represent the ore. These small dots represent other particles we don't need, right? Now, what can you see here? The particles we need, these ones, are they close? Are they close or are they separated? They are separated, right? Now, what made them to be separated? It's not this man that are shifting them apart. So by the time I remove all these things, would they come closer? Good. So that is the meaning of concentration. To concentrate means to make something come closer, come together. So by concentration of all, we mean separating all from what? Earthy impurities. From what? So you can make small note here. This is the process of separating ores. This is the process of separating ores from the earthy impurities. Earthy impurities. All the earthy impurities are called gengu. Are called what? Are called what? Gengu in metallurgical industry. Gengu or matrix. Gengu or what? Matrix. If you hear gengu, we're talking about what? Earthy impurities. Those things in the soil that accompany the ore. So ores, are they pure substance or impure substance? Impure, right? So they're always accompanied by other things that may be valuable or not valuable. So those things that accompany ore are known as what? Or we call them what? Gengu or matrix. Can you think of any gengu? Can you think of any earth impurity? Sand, thank you. Sand. Sand is correct. Tell me another one. Tell me another one. Sand is correct. This one is also there. This one is also there. Even this one too. All these things, they're all gengus. Sand. Stone. What about stones? Huh? All those small stones. That is correct. All those small stones. So they're all gengu. So when we talk about gengu, we are referring to sand, clay, mica, feldspar, all these impurities, all these earth impurities that normally come with ore. Okay? So we have to do what? Separate them from the ore. Is that right? Now, there are processes used here. There are processes used here. One of the processes you can use for concentration, processes used for concentration of ore. Used for concentration of ore. There are many processes. What are the possible processes that can be used to concentrate an ore? You can use froth flotation. You can use what? You can use what? Froth flotation. What does it mean of froth? What does this word mean? Who can tell me the meaning of this? What does it mean? Do you know what is bubble? Foam. Okay? So large quantity of bubbles can happen. Thank you. So you can see this word. So you can you understand the meaning of this now? Nukufu megini. Nukufu meregini. Serenen wakwezoku. Bubbles serenen. That is the meaning of this. So we can see that. Now, is there another process that can be used here? Apart from this, you can also use a method known as leaching. You can also use leaching. But let me tell you this. Which kind of ore do we use this one for? This one is suitable for what? This one is suitable for sulfide ores. For what? Sulfide ores and low-grade ores. Low-grade. Ores that are of low grade. That's what you use froth flotation to separate or to concentrate. Another one, this leaching is suitable for bauxite. It's suitable for what? Bauxite. So bauxite and so on. I'm just limiting you to basic things you need to pass the exam. I don't need to load you with many things. Now, they can ask you in exam, which of the following method can be used to concentrate aluminum ore? What is aluminum ore? Bauxite. So it's leaching. Have you heard of leaching before? In normal sense, leaching has to do with what? Washing down of what? When rain falls, what happens? They will dissolve loose minerals on the earth, right? On the surface, and wash them what? Down. So the word leaching has to do with the dissolving. Dissolving. Dissolve something and carry it away. Is that right? Dissolve. We're coming to that. Now, there are other methods like magnetic separation. When do you think you can use magnetic separation? When can you use magnetic separation? When maybe the ore is magnetic, right? If the ore is magnetic, okay, and then the impurities are non-magnetic, you cannot use what? Magnetic separation. Sometimes you can also use hydraulic washing. Give me an example of ore that can be separated by magnetic separation. This one is suitable for what? It's suitable for magnetite. Magnetite is known as lodestone. Known as what? Lodestone. What is the meaning of lodestone? What does the word load mean? L-O-D-E. Load means uzo, way. Way. Uzo. That is meaning of load. When in our church, and assassin that number, Imanda number chief road as a load. Obro load in can wine your mouth from Kena Mam o. Sanataba. So L-O-D-E, load. Lodestone. If we mean in the beginning, directional stone. Can you imagine when I buy a lodestone? Because Nambobo, the British, Mbane webe compass. On a gosi sailors. Okay, mandibu sailors. Ndi na anyo bombiri. Fachi haji megini. On a serve her as what? Magnetic compass. Not direct who's eba kwesirisi. North or south. I imagine again. Load stone. Stone negosi mad again. Also way. Okay? So only directional property. And that is why it is called lodestone. It's natural. True or false? It's natural. It's magnetic. So you can separate it from other things. So what have other methods, though that one is not common, I will not tell you about it. They can ask you about that in exam, but just know it. Hydraulic washing. They will not ask you a question about that. Hydraulic washing. So they can only ask you question from the first three. The first three. Now, very soon my first question is coming. All right. Let me ask you the first question now. Though I will clean this, I wouldn't like this to be here before I will ask the question. Let me get the question. The question says, you can check it in your JAMB question 2005, question 10. That's what we're about solving now. 2005, question 10. It says, which of the following ores can be concentrated by froth flotation? They gave you option A, nitride ores. They gave you B, chloride ores. They gave you C, oxide ores. They gave you the sulfide ores. Sulfide ores, right? All right. Okay, we're coming. Another question is coming. Now, let's move forward. These are possible processes you can use to concentrate what? Concentrate or purify ore, right? So, froth flotation is suitable for what kind of ore? Is it sulfide ores? And leaching is suitable for what? Bauxite. Okay, let's now move forward. Now, the next stage, I told you, remember we are discussing basic stages in what? What we are doing is summarizing metals, so that if you are studying metals, you will now be understanding where they are coming from. After this one I'm doing now, you see I've summarized metals, extraction of metals. So anything you are now studying, you can now understand the terms used there. Now the second stage, the second basic stage in metallurgy is conversion of ore to oxide. Conversion of ore to what? That is where it is necessary. Conversion of ore to what? Oxide. What are the possible processes we can use to convert an ore to oxide? This can be done by processes. What are the processes used here? Possible processes. We can use what? Processes used to convert an ore to oxide. What are the possible processes? We can use what? We can use roasting. We can also use calcination. Roasting is usually suitable for sulfide ores too. For what? It's suitable for sulfide ores. We're going to look at what are the sulfide ores before I will ask you another question now. Suitable for sulfide ores. Class, what does roast? To roast something mean? Have you seen people roast corn? When they roast corn, what do? They place it on fire, right? Do they cover it? Did they cover it? Did they protect it from air? Do they expose it to air? So roasting is simply roasting in presence of what? Oxygen. Heating in presence of oxygen, rather. Heating an ore in presence of oxygen to convert it to oxide. Possibly when it is a sulfide ore. Okay, now, what about calcination? Calcination can be done for several reasons, though there are many types of roasting. I don't want to take you there. What we need is basic knowledge. That's what we need. So, when we talk about calcination, calcination is very, very valuable. It is not all cases that roasting can work. So we're going to see where calcination can work. We're coming there. Now the third stage in metallurgy. The third stage in metallurgy is, that's the third stage, is reduction of ore to crude metal. This method is something as saying extraction of metal from ore. Metal from the ore. That is a reduction. What do you mean by crude? Crude means what? Something that is what? Impure. Something that is what? Something that is mixed with other things. That is crude. That is meaning of crude. Somebody say, which ores are hydraulic washing used for? I told you, remember what I told you before? Did I say something about this? I said you don't need it. There's no need of telling you everything just to tell you things. No. We have targets. There are reasons why you are here. All right. Now, reduction of ore to crude metal, extraction of metal from the ore. Now, what are the various processes used here? Processes used to reduce ore to metal. How can you reduce an ore to metal? What are the processes used that can be used? Can anybody tell me one method that can be used to extract a metal from the ore, or to reduce an ore to the metal? Pardon? Thermal reduction. Thank you. Another one. Huh? You're not doing anything. Come. Where are you going to? Okay. All right. You say something? Electrolysis. Thank you. Another person? Chemical. Do you know the meaning of chemical reduction? Using chemical to reduce. I want you to just always know the context, the contextual meaning of what I'm saying. When you say chemical reduction, we mean what? Using chemical to reduce. So it is not a name. It is not a process. It is not a name. So we're interested in specific words, terms. Because there are many chemicals. You have not said anything when you say chemical reduction. You have not said anything. So what are the possible processes? You mentioned electrolysis. Though electrolysis is usually the last resort when other methods have failed us. How many of you have heard of something like smelting? Have you heard of this? Smelting. Smelting. What is smelting? Okay, note down. Let's know what smelting is. Everybody. Smelting. What is smelting? Smelting. Smelting is the process smelting is the process of touch that girl. What are you doing? All right. Smelting is the process of reducing an oxide, okay, to metal in the furnace. Reducing what? An oxide to what? Metal. In where? Where do that happen? Where does that happen? It happens in furnace. It happens in furnace. By action of coke. By action of what? Coke or carbon 2 oxide. By action of coke or carbon 2 oxide. By action of coke or what? Carbon 2 oxide. Now, class, what is coke? Is it what we drink? What is coke? A type of carbon, a form of carbon, right? Now, tell me one property of that thing you call coke. Tell me what you know about it. Can you think of one thing you know about it? Is it a reducing agent? Is it a reducing agent? Is it a reducing agent? What about carbon 2 oxide? Is it a reducing agent? Yes, carbon 2 oxide is a powerful reducing agent. Coke is also a powerful reducing agent. Remember we're talking about reducing oxide to what? Metal, right? So we need something that can do the job. Now, is coke a chemical? Is coke a chemical? Excuse me, is water a chemical? Huh? Everything you can see is a chemical, including you. You're a chemical. You are a chemical. If you don't know, you're a chemical. So when you say chemical, don't think that chemical is in heaven. No, it's you. It's everywhere around you. The air you inhale, is it a chemical? Yes, air is a chemical. So my question is coke a chemical? Coke is a chemical. Is carbon 2 oxide a chemical? It's a chemical. And if it's a chemical, when you use coke or carbon 2 oxide to reduce a metal reduce an oxide to a metal, is it chemical reduction? Is it chemical reduction? I ask a question again. If you use coke or carbon 2 oxide to reduce an oxide to a metal, is it a chemical reduction? Why is it chemical reduction? Did you use chemical to do the job? What chemical did you use? Coke or carbon 2? So when the chemical you are using to reduce an oxide to what? To metal is coke or what? And the process happens in a furnace. Then what do you call it? Smelting. Tell me one metal you know that can be extracted by smelting. Tell me one metal you know that can be extracted by smelting. Is iron? Iron. Have you heard of blast furnace? There are many types of furnace. That's why I did not mention blast furnace. Blast furnace is normally used for iron and even lead. Okay, now we're coming to ores. I'll give you basic ores of metals now. Immediately after this. Then apart from smelting, there is also another method known as what? Electrolysis. You know, you have heard of this one, right? We'll come to that. Apart from electrolysis, there's also another method you can use, atomic hydrogen reduction. There is reduction. You can say reduction with atomic hydrogen. Why do I say atomic hydrogen? Hydrogen molecules are not reducing agents. Hydrogen atoms can only function as a reducing agent when it is in atomic state. In what? Yes. When it is in atomic state. There is also another important method that we'll also use. Have you heard of this? Have you heard of this one? You can use an ore to reduce the, you can use an ore to reduce itself. You can use an ore, for instance, a sulfide ore to reduce the same ore. How do you do that? What you do is that you convert part of the ore to another form like oxide, and now react the sulfide with the oxide. The sulfide, while the oxide is trying to oxidize the sulfide, then it gets reduced to metal. That's Bessemerization. It's carried out in Bessemer furnace, Bessemer converter. That's why the process is called Bessemerization, is it right? It's called self-reduction. Then another basic thing again you need to know is apart from Bessemerization, there is also another method you can think of. Somebody mentioned thermal reduction here, isn't it? Thermal reduction, I will give you, I will tell you when thermal reduction can be used. There's also another one anyway. How many of you have heard of this? What is it? Aluminum what? Thermal process. Then the sixth method that can be used is thermal reduction. Thermal reduction is suitable for mercury. Suitable for what? So please note it here. Suitable for mercury. For mercury extraction. Suitable for what? Mercury extraction. Suitable for mercury extraction. So what? So I gave you 6 processes that can be used to do what? Extract metal from ore, right? Starting from what? Smelting. Can you tell me one metal that can be extracted by smelting? Can you tell me one metal that can be extracted by smelting? Iron, right? Lead, tin, no, not silver. Tin. Okay? We'll come to them. Don't worry. Electrolysis. Can you tell me any metal that can be extracted by electrolysis? All the very reactive metals, right? Like what? Sodium, potassium, calcium, magnesium, aluminium. Yes. Strontium, barium. All these reactive metals. Yeah, zinc. Zinc is extracted by smelting, mainly. It's just some fraction of zinc that is extracted by electrolysis as impurities. Yes, zinc is extracted by electrolysis, I know. But that's not the main method. Okay, so now, the 4th stage. Remember I told you how many basic stages of metallurgy? I told you there are how many? What are what did I tell you? How many number did I mention? I said, how many basic stages of metallurgy have I mentioned now? 3. Remaining, and how many did I tell you they are? No, I did not say 6. I said 4. So the 4th stage now is purification of metal. Purification of, after extracting the metal, you purify it. Purification of metal. So what are the basic processes used to purify a metal? Can you purify a metal by electrolysis too? Yes. Some metals are also purified by electrolysis. Touch that girl there. Touch that girl. Are you okay? Purification of metal. Can you tell me any method that can be used to purify a metal? Electrolysis, yes. These are processes you can use. Electrolysis. Electrolysis is a process you can use here. Another one. Basic ones. Basic ones. Another one. Another one. Can you tell me any, if you go to jump past question now, you see this. Can you tell me any method that you purify by electrolysis? Mention one. Just one. Just one method that you purify by electrolysis. I'm waiting for just one common around. Very important. That one is, in fact, the first method that was, in fact, that started to be purified by electrolysis. Copper. So copper is purified by electrolysis. So the process that is called electrolytic refining. So copper is purified by electrolysis. Copper. Apart from copper, you also have what? What else? You can talk about sodium. Aluminum is also purified by what? Electrolysis. So, aluminum. We'll come to them. This is just summary. So that when we'll be talking, you'll be following what we're saying. Now, after electrolysis, any other method you can employ to purify, you can also employ what? Zone refining. Yes. This one is suitable for purifying. This is the actual, in fact, the method that is used to purify silicon and germanium. Silicon and what? Germanium after extraction. When we need the metal in high degree of purity, just like in electrolysis, you can employ zone refining. Zone refining. You can also use selective dissolution. Selective dissolution, where you choose a metal that is soluble in a particular solvent, dissolve that one, and filter others away, and then recover that metal from the solvent. You also have liquation, and so on. So the only thing that you need here is just the phase 2. The phase 2 is only one jam can ask you. The phase 2, electrolysis. Can you remind me 2 metals again that can be purified by electrolysis? Don't forget copper. Copper, aluminum. Thank you. So this is it now. Now, I haven't talked about this. I want us to look at metals and their main ores. They are what? Main ores of metals. The main ores of metals. Some important metals. We're not going to finish all of them, so you research others. So, metals, main ore. Main ore. Main ore. Let's start with sodium. What is the main ore of sodium? The main ore of sodium. I hope you remember what an ore is. What is ore? You say what? Minerals whereby what? That you don't need to spend too much money to extract, right? Now, we now have the main composition. The main component. Is ore a pure substance or impure substance? Which means it's a mystery. It's made of many things, right? Thank you. Now, sodium. Who can tell me the main ore of sodium? Rock salt. Say rock salt. No eje si ofe. No n'ime ana ka nnukwu okwute. Egwupụta n'ime ana. Agbarie ya. Wee purify ya, treat ya. Or sometimes I am wait here from sea. Question is right. You fetch the water and begin to concentrate the salt to remove other impurities that are not wanted. So, but this we don't extract sodium from seawater. We extract sodium from where? Rock salt. What is the main composition of rock salt? Please, sir, can you show us a picture of rock salt? Rock salt. The main composition is sodium chloride. Is what? That is the main component of rock salt. So when you hear electrolysis of rock salt, pure rock salt, you are talking about electrolysis of what? Sodium chloride. In fact, this topic is necessary before you can even go into electrolysis. So that by the time you'll be talking about, of course, if you have done metallurgy before doing electrolysis, life will be easy for you. Are you coming? Thank you. Rock salt. Look at it. Can you see that? You can't see the picture? Okay, enlarge it, please. Aluminium. What is the main ore of aluminium? What is the main ore of aluminium? Bauxite is correct. What is the main component of bauxite? Who can tell me the main component of bauxite? If you go to your jam pass question now, you can answer from what I've been saying since you can answer no less than 20-something questions. All this is I've been saying, if you go to your past questions, you'll be seeing them. Bauxite, what is the main component? Can you see it now? Good. Do you know why it is, does it have color? The salt we use, does it have color? But this one has color, right? Because of impurities. Because of what? Impurities that follows it. That's why it is colored. But those white ones are now the ray salt, the ray salt, right? Sodium chloride. You know, it's usually white, true of us. So, but all those ones you have impurities, ion substances. Now, bauxite, you cannot remove it. So, what is the main component of bauxite? Aluminum oxide. Aluminum what? That is the main component. Aluminum oxide. That is the main component of bauxite. Then we have an ore. Right? The what? Chemical formula. What is the chemical formula for sodium chloride? NaCl. What is the chemical formula for oxide? Capital A, please look up. Capital A, like this, am I correct? Am I correct? I'm wrong. Why? Where did I get it wrong? If I write two capital letters, that means I'm referring to two elements, two different elements, right? But I'm referring to aluminum, so the L should be what? Should be small. And this is small l, right? So I have this subscript 2, then O subscript what? Aluminum oxide. I mentioned a mineral here that is aluminum oxide, corundum. Do you know corundum? Corundum is also aluminum oxide, but harder form. Bauxite and corundum are polymorphs. We'll come to that. Now, there is another ore, zinc. What is the main ore of zinc? The main ore that we get zinc from, that is what? Sphalerite. Sphalerite. If you don't call it, it is also known as zinc blend. But in jam we will not use that term zinc blend. Because JAM cannot ask you which of the following metals is extracted from zinc blend. Is there anybody who cannot answer that question? Imagine JAM ask you which metal is extracted from zinc blend. Of course, you are going to rush here. Even if you have not seen it in your life, nothing will stop you. No, there is no Satan. There is no equation that can stop you from choosing zinc. So you must choose zinc with common sense, even though you are not sure what I'm saying. But the moment they use sphalerite, cheje. So sphalerite is the main composition is zinc sulfide. Is what? Zinc sulfide. Zinc sulfide is ZNS. 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 Zinc sulfide. Now you also have this. This one, lead, is also an important metal. Who can tell me the main of lead? The main of lead is what? Galena. Galena. The names, all these names I'm calling are coming from where? All these names are derived from local places. The places where the ores are mined. Want to say something?
Good afternoon, everybody. Please, I want to make this clear to every single person that is writing WAEC with us, both WAEC and NECO. Now, this is your form. This form now, they sent it to me yesterday, and they said I should do the last corrections. So please, if you know that you gave me a wrong date of birth, if they use that wrong date of birth, you have to go and correct it. That is after your result has come out. You have to go and correct it with nothing less than 20,000. And according to what they told me, they said there's no correction again. Any mistake you do, that means you write another one. So for you not to be in that category of persons, please, immediately after this class, if you're not staying for the WAEC class, let me say if you only register for JAM classes only, before you go and you are going to write this exam with us, before you go, just meet me and do all the corrections with your name and your date of birth. If you fail to do it, and some of you even wrote female when you are a male, I don't know whether you people are like Americans now. So please, just make sure you correct those things with me so that I will be able to submit this thing today. You get? And wait for your final registration, please. Thank you so much.
All right, back to business. What is the main of lead? Galena. So, what is the main composition of galena? Lead 2 sulfide. Lead 2 what? What is the formula? PBS. Who knows the color of galena? Who have seen galena in his or her life? Koyefunugo galena anya. Iga na ogbo etifu galena. Okwi na-ete ọtanjele. Okwi me ife bụ ọtanjele. Iya na-ede n'anya. Okwi me ya na-adị black. Ọ galena ka ị na-ede n'anya. Uncle, go see how the thing na picture ka afọ ya. Okay, fear the picture. It shine if you go the thing I wanna shine, I shine. Eh? Never. Or the black or not the black? Or the black. On a shine, I shine. Wrap the picture in our fair. But if you the original picture fair, on a bouquet. I shine, I shine. The dark, sharp, black. All right. So, the next, I will soon stop here. Now, look up. Look up. For you have metal like copper. Who can tell me the main ore of copper? The main ore of copper. The main copper ore is copper glans. Copper glans, which is copper 1. The main component is a copper 1 sulfide. The formula is Cu2S. Copper 1 sulfide. You also have a metal called tin. Called what? Tin. The main ore of tin is cassiterite. Cassiterite. Also known as tin stone. Tin what? Now you see, do you think John will call it tin stone for you in the exam? What would they call it? So they'll ask which of the following metals is extracted from what? Cassiterite. If you go to tin, you can see these questions there. All these things are there. You know, they do give you this. The main component is what? Who can tell me? The main component is tin 4 oxide. Tin what? Tin 4 oxide is the main component. The formula is what? SnO2. Another boy tin stone. Stone eba na ewepụta tin. I don't like reading it because this might be bomb. This is what Bola Ige received and died. So you can, Uncle, please increase your writing. Okay, this is a nice one. But you could have just raised your hand up. If you need anything, just like this. Or in a mifere. In a mifere. All right. Now, you also have this. I want to tell you basic things. Silver. What is the main ore of silver? The main ore of silver is argentite. Argentite. What is the main component? Silver sulfide. Now, I want to ask a question. Should I ask a question? Have you seen new electric iron? The pressing iron. New one. KKS on our church. Is it very white? Sparkling, right? With time, what happens? True or false? What is causing it? Eh? A silver coat eba in our church. Is that place coated with silver? That place is coated with silver. That place is coated with silver. Over a long period of time, as you are using that iron to press wet clothes, hydrogen sulfide in air will begin to react with the silver, producing silver sulfide. Silver what? Which is black in color. Which is what? So that black thing you see in your iron that begin to appear in the silver coated iron, after a long period. You know what I mean by iron? I broke iron nke gate. Pressing iron. Good. So that is silver what? Sulfide. It is silver sulfide that causes that blackish deposit. Is that blackish deposit anyway? The blackening of silver coated articles is caused by this. So and so on. Now I don't want to include iron here, but let me include it anyway. Iron. Who can tell me the main ore of iron? The main ore of iron is what? The main ore. Iron has 4 ores, but you have the main one. What is the main iron ore? Huh? Pardon? The main iron ore is red hematite. Red hematite, which is the main component is iron 3 oxide. Iron 3 oxide. The formula is Fe2O3. Now, but I would like to let you know of iron ores. Iron ores. We have 4 iron ores. I'm going to ask you some questions from them now. The main one is what? Red hematite. Red hematite. What is the formula? Fe2O3. Which compound does this formula represent? I don't like calling it this. Just know that this is the main component. What compound has formula Fe2O3? Iron 3 what? So can you show us red hematite in the board? Red hematite. So you have this. You also have magnetite. What's another name for magnetite? Lodestone. Is it a magnet? Is it a natural magnet? It's a natural magnet. For the fact that it exists natural is what? A natural magnet. I'll ask some questions now. You can call it lodestone. Then what's the next one? The next one is what? Who can tell me? The next one is what? Who can tell me another iron ore? Apart from these 2 I've mentioned, who can tell me another one? Who has idea? Anybody? Nobody. You have this. You have what you call limonite. Limonite or brown hematite. Brown hematite, which is, it has this formula anyway. This is the main composition. Then finally you have this one, siderite, also known as sphatic iron ore. This is the formula, is iron 2 carbonate. There's one that is not an iron ore, which is iron pyrites. Iron what? It's not an iron ore. It's an iron mineral, but not an iron ore. Remember, all ores are minerals, but not all minerals are what? True or false? What is now ore? Minerals you can get metals from. True or false? So, what I've just summarized for you is just ores, metals, where we get metals from. So, what we'll now be studying is how to get metal, each metal from each ore, and then we select. Of course, in your JAM, any of this could come out. Any of them. Any of them. Can I have your past question? Maybe let's see one or two things. I will need pre 50 to be easier for me to locate something there. That's pre 50. Pre 50 so that I can easily locate what I want to locate. Now remove your eyes from the board. Let me ask, close your eyes and answer these questions. Close your eyes and answer the questions. I want all eyes closed. Is there any eyes that is open? Some eyes are still open. Is there still any eye here that is open? You can close one and open one. Okay, now the question goes this way. Okay, now listen to these ones. They said here, that was 1999, question 40, and repeated in other years. It says, a metal that can be extracted from cassiterite is what? Is it tin? Do you see one thing, If you read and know something, you don't spend less than a second in choosing your answer. True or false? Sometimes people complain that JAM did not give them time. Is it true? You were given enough time. It's just that you don't know the answers to the questions. So what happened? You were busy thinking. You will read the question. If you cassiterite an option, if you sphalerite is if argentite, you go option A, argentite. Echitekwan ubochi onko ukwu argentite na class. In that class again, cassiterite. Ine ekwu ya otanu. Mgbe ị na-ekwu ya ma na time na-aga. So mgbe ị eji wata na time na-aga mgbe when your computer will shut. Anya wee saa gị. Wee tete n'ụra. Now, listen to this one. There are a lot of questions in what I've done, but I can't just find them yet. Before I proceed, who can, of all this iron ore, which one is the commonest? In JAM, listen, not everybody is aware that this is called hematite. In exam, listen, in exam, just know it as hematite, magnetite, limonite, and what? All these names I gave them here, not everyone is aware of it. So it is the first name you should be, conversant with. Now, which one is the main iron ore? The main one? Hematite. Remember I told you for JAM, forget about the word. But this is the right thing. Now, what if there's a question that can come? And this question goes like this. Which iron ore is the commonest one? Commonest. Not even a commonest. You can easily see it around. Which one? Lodestone. Thank you. People use lodestone. Iron condemn people use it to pick some things, isn't it? They used to pick pieces of nails and other things. They used to pick things. It's also found in physics lab. That is, if your own school has lab. Because some schools don't have lab. They only have lab a week to WAEC. They will go and clean the lab, Uh-huh. Okay, another one. Who can tell me? Who can tell me? In fact, let's look at bauxite. Extraction of aluminium. Listen. Metallurgy of aluminium. Class, tell me what is metallurgy again. What is metallurgy? Huh? Uh-huh. No. Say there was something I said. Uh-huh. Science and what? Extracting metals from the ores and purifying them, right? Followed by purification, true or false? So now, when I say metallurgy of aluminum, what am I talking about? Science and technology of what? Extracting aluminum from where? From what is the ore of aluminum? Is it bauxite? That is correct. Science and technology of extracting aluminum from bauxite, followed by purification. Now, what are the, did I tell you stages involved in metallurgy of metal? The first stage is what? Concentration of what? Concentration or purification of the ore, right? Why are we purifying? When we are purifying the ore, what are we separating? What do we want to remove? Earthy impurities, right? What do you call those earthy impurities? Gangues or matrix. Thank you. Now, what are the impurities in iron ore? Major impurities in what? Iron ore. Sorry, bauxite. Major, first of all, listen, we have gangue and additional impurity. Can you tell me any gangue you can find in iron ore? I mean in bauxite. Gangue, that is earthy impurity, main earthy impurity. What is the main earthy impurity in iron ore? I mean, I don't know why I like iron ore. In bauxite. What is the main earthy impurity in bauxite? Who can tell me? The main iron impurity, the main earthy impurity in bauxite is what? Is sand, or you say silica. Silica, or you say silicon dioxide. They can accept this even though it's not that too correct. Silicon dioxide. Silica is pure silicon dioxide. There's a difference between sand, silica, and even silicon dioxide. Okay. I am not give you. Now, what is the main earthy impurity in bauxite? Sand, right? Now, we have additional impurities other than what? Earthy impurity. Sometimes, apart from the gangue impurities, you still have another additional impurity that are not gangue. Why are they not called gangue? Because they are valuable. They're what? So what is the major additional impurities? In bauxite. Who can tell me the major additional impurity in bauxite? Can you tell me anyone? The major additional impurities in bauxite? iron 3 oxide, iron 3 oxide, another one, titanium 4 oxide. What is formula for iron 3 oxide? Fe2O3. What is formula for titanium 4 oxide? TiO2. Titanium 4 oxide. These are the major additional impurities in bauxite. But the main earth impurity in bauxite, the main gangue is what? Sand, right? Now look at it here. If you have your past question, you can check. You can check 1986, question 36. What are the stages in metallurgy of aluminum? The first stage is what? Leaching. Leaching of bauxite. Did I say that leaching is suitable for bauxite? Did I say so? Leaching of bauxite. What does leaching mean? Dissolution in what? Dissolution in concentrated sodium hydroxide solution. That is called leaching. In concentrated sodium hydroxide solution. Dissolution in concentrated sodium hydroxide solution. That is the leaching. The second stage in metallurgy of aluminum is calcination. Then the third stage is electrolysis. Electrolysis of alumina. The fourth stage is electrolysis, electrolytic purification. So these are the summary of metallurgy of aluminum, how aluminum is extracted. These are the processes involved. So I have just 2 more minutes to spend with you. Emesi ankpoti meto yin agwa aka. Ngwanaye ka ngosi gị na ebe a. Ọkwa ị na-anụ maka amphoteric oxide. Ịnụnugo maka amphoteric oxide. Aluminum oxide, is it amphoteric or not amphoteric? Gịnị bụ amphoteric oxide? Just ka m kwuo nke ahụ ịma. O mechaa m ga-agwa gị ihe o meanere. The real meaning. Mana ka m kwuo nke ahụ ịchọ ịnụ. Amphoteric oxide bụ oxide nwere ike react with acid or react with what? Base. Akwa eziokwu? Thank you. Nke a ka maka m kwuo ya ụta ka anyị rapụ ụta. O mechaa m ga-agwa gị the real meaning. Now, aluminum oxide you said is amphoteric. True of us? It's amphoteric. Now, tell me the things that go with bauxite. Apart from aluminum oxide, is there another thing that accompanies the bauxite? What are those things you find in bauxite apart from aluminum oxide? What are the things? Tell me the things that are clumping silica. Thank you, right? What else again? Iron 3. This is the main disturbing thing here. We need to ensure that iron is removed so that the quality of aluminum will not be affected. Or else, if you use aluminum to produce pot, that pot will be rusting. Will be what? So we ensure that iron is completely removed from aluminum, so as not to affect the quality of the aluminum produced. So how do we do this? Remove this aluminum oxide. Look at the reason why metallurgy is called science and what? Technology. You have to think. When you see something, you begin to study it. Can you tell me the 4 basic stages of science? If you want to study something as a scientist, can you tell me the first 4 stages? Observation, hypothesis, experiment. I disagree with theory. Conclusion. You make your word. Conclusion. That is the first stage. When you make your conclusion, and many people, listen, when you make your conclusion and put it forward, and other people use the same thing, listen carefully. They carry out the same experiment you have carried out, and they find the same result with what you have found, then your conclusion becomes what? A theory. Are you with me? Your conclusion becomes a theory. Now, when almost the entire world accepts it, it becomes what? A law. So law and theory are not scientific methods. They're not based scientific methods. They're not. Okay? They're not. Now, so you have this iron 3 oxide. This one is a basic oxide. It's basic. Okay? But aluminum oxide is what? Amphoteric. Remember the problem, the challenge is how do I separate all this iron from the bauxite, right? You have aluminum oxide there, you have iron there, iron oxide, you have sand. How do I separate this? For you to find a way of separating them, you have to think like a scientist. Carry out a series of experiments, all your knowledge, apply them. Now, the first thing to think of as a scientist is the fact that this man is a base, while aluminum oxide is what? Amphoteric, right? Now, sodium hydroxide. Will a base react with a base? Do you think that sodium hydroxide will react with this? It will not. But can it react with aluminum oxide? Why? This one is amphoteric. So when it sees aluminum oxide, it will now start to act as what? Acid. You see the science here now. So it cannot act as acid. So it will dissolve. So aluminum oxide will dissolve in this. But this one will not what? So it's removed by filtration. By what? You filter it. You see why it is called leaching? Leaching because this man dissolves, isn't it? You dissolve aluminum what? Oxide. That's why the process is called what? Leaching. So I'm going to stop here now with giving you these questions. You know, when you sigh, you remove 1 year from your life. You better be happy. Let me tell you something. You're supposed to be happy. Even if somebody slap you, try to be happy. Now, let me tell you this. Do you know lion? You know lion? Do you know why lion dies fast? Lion doesn't live more than 15 years. It dies easily. But tortoise lives up to 200 years or more. Why is tortoise living long like that? It doesn't look for any problem. igafeche iga ebe ị na-aga ọpụtakwago ebe ọ na-aga. But lion, when he sees somebody, begin to roar. Every time it is angry. And ki na-ewe may increase that is, you are stressing your heart. You are stressing your organ. You are increasing the biochemistry of your body. And this reduces your lifespan. That is why sometimes there's how you can get angry, you can have cardiac arrest and die. Yeah. So you should be always happy. So now listen to this question, you go. When you go home, you look for others. The iron, listen now. The iron 3 oxide impurity in bauxite can be removed by dash. Are you listening now? The iron 3 oxide impurity in bauxite can be removed by dash. A. Fractional crystallization in acid solution. B. Dissolution in sodium hydroxide and filtration. C. Extraction with concentrated ammonia and reprecipitation. D. Electrolysis of molten mixture. Is it B? Yes. Clap for yourself. Then finally, aluminum is extracted commercially from its ore by dash. A. Heating aluminum oxide with coke in a furnace. Heating aluminum oxide with coke in a furnace. Which method is this? What process is this? When you heat an oxide with coke in a furnace, what method is this? Smelting. Is it what we use to extract aluminum? No. The second stage says, the second question says, electrolysis of fused aluminum oxide in cryolite. C said treating cryolite with sodium hydroxide solution under pressure. This say heating sodium aluminum silicate to a high temperature. What do you say? Is it B? That is electrolysis of what? Alumina. That's the third stage in metallurgy of aluminum. The first stage is leaching. The second one is calcination. This is electrolysis, and purification is what? Electrolysis as well. You want to know? Is that what? The option here is supposed to be B, electrolysis of fused aluminum oxide in cryolite. Okay? I wish you good luck.